Okay, it's we're at 3:02 after. It is our honor here at the Minnesota Geospatial Advisory Council's Emergency Preparedness Committee to have an esteemed group from One Concern to be on board to present. Greg, I will let you go through and introduce your team, and then from there, off we go. So again, thank you again.
No, thank you. And thank you all for the kind invitation. We appreciate getting this organized and joining you today. And as Craig said, typically when we get invited to speak, we spend a day on a plane on either end trying to do that. But Zoom has made this much faster and more efficient for all of us. So thank you. So I'm Greg Brunell with One Concern, and I work for Craig. And everyone is familiar with Mr. Fugate, who was the longtime serving Florida State Emergency Management Director through some of the most active period of hurricane in the state's history, several hurricanes in 1 year, and then went on to serve with Mr. Obama for 7.5 years as the FEMA administrator, really revolutionizing preparedness and response in this country. So we're very honored to have Craig join us today. And Anand is up here in the Northeast as well. Right as you were getting on Anand, we were discussing where we were physically, and he's in Boston, or just outside of Boston. And he leads our solutions team. And Anand, can I ask you to just explain real quick what the solutions team does, and maybe a little bit more about your background?
Sure. The solutions team at One Concern is focused on helping our customers understand the value of our products and our technology. And so we typically will work with customers to understand their use cases and then implement them. And my background is in AI. So I did my graduate work at Stanford, and I had a company before in the AI space. And so I'm really excited about this conversation and meeting all of you.
Great, thank you. And with that, I'd like to turn it over to Mr. Fugate for some opening remarks and conversation. And then we'll talk about what One C's up to.
Well, thanks for having us. Going as far back as Hurricane Andrew, one of the challenges that Florida had, and emergency management in general, was when I started this business, we used paper maps, USGS maps. That was as good as it got. And as the evolution of graphic information systems took place, we kind of saw, it was interesting. It kind of like followed the path of, we went from paper maps to maps we could draw on, but were essentially still paper maps, except on the computer screen. And as we got better at it, we started looking at collecting information, moving this really into this idea of a graphic information system versus just maps. And so I've kind of watched this go to whole length. And one of the questions I've had it at FEMA, but when I got out, it was a question that I was asking that One Concern is trying to answer. And that is, why do we have to wait until a disaster happens to find out how bad it could be? I've been to a lot of places, and it's amazing to me how often I heard, I lived here all my life, I never knew it could be this bad. And I'm like, why? We got the data. But one of the challenges is most of our information about hazards are static. We show what the historical risk is, or we show, like from USGS, shake maps and stuff like that. But it doesn't really translate into, well, how bad could it be? What all gets affected? And so we were trying to take this idea that geospatial data in the real world isn't static, it's always changing. And we could do, and the project actually started out looking at seismic. But as we've been going into flood and other things, we just signed a new extension in Japan with a major insurance company for about 100 million. So it's progressed from when I joined the company. But it's asking this question of, can we forecast, not the event. We're not into forecasting earthquakes. We're not into forecasting how much it's going to rain. But we got this system down in the Gulf, may become Claudette, may not. But if it comes into the Louisiana coast where they've seen rain, heavy rain for the last couple of weeks, and it dumps 20 inches of rain, we wanted to do something besides just asking, well, what all is going to flood? Because that's one question we want to answer. The other thing we want to ask is, how does this impact the community? FEMA created the term lifelines, looking at various types of infrastructure. We see a lot of dependencies that when you start looking at a type of facility, that too often the facility is the focus of the risk analysis. But it turns out that that facility may have a lot of dependencies that could be impacted as well, while the structure or that point on the map is less affected. An example was Stanford had constructed a new hospital. And so when they looked at the seismic risk there, they poured a lot of money into this hospital. It's built with the best data they had on earthquake, on seismic protection. You run every model we couldn't get much of anything to crack. It was built for earthquakes. So, the assumption was, okay, well, the hospital is going to be fine after an earthquake. And that's how a lot of the planning would take place. But when you started looking at other things like power, well, they got a generator, they got plenty of fuel, they knew power would be out. Okay, they're set. We kept going down and looking at interdependencies, and it turned out there was one thing that Stanford had not factored into that design, and that was, in California, they use aqueducts to move water over hundreds of miles. And it turns out those systems are extremely fragile in seismic events. And so where Stanford had built this hospital, put in the emergency power, was set for the biggest earthquake and still be able to provide services, their Achilles heel is a water system that literally transports waters over hundreds of miles over systems that they had never modeled. Their assumption is it gets to them, that's the local supply. And it was, that kind of work that we started realizing that when we talk to a lot of companies, when we talk to people that are planning, they tended to plan for a point on the map and not look at the function of that point on the map and all of the things that connect to it. So everything from, looking at some companies that up in the Northwest, they asked us to look at their facilities, and we did all the model stuff. It turned out their facilities are in pretty good shape. It's going to take an event that's so catastrophic for their facility has much impact. But it turns out, and those of you that in government know, we tend to build roads and bridges under low bid scenarios, minimum standards, and we'll do just enough to get federal highway funding and no more. Turns out those systems started failing at a much earlier rate than the structure. Another thing they hadn't thought about was their workforce. They had never looked at how these disasters would impact their workforce housing. There's a company we looked at in the central part of the U.S. that's impacted by the New Madrid earthquake. And again, their facilities, they had thought a lot about that, getting them back up, all the things they would need to be operational. They never really looked at, could their folks even get into that facility? And the area they were in, the seismic risk, and again, where not a lot of construction was built for seismic, they were not prepared for not being able to get their workers in. We're looking at flooding. This is the classic one where you're very familiar with the National Flood Insurance rate maps, but too many people think those are the flood maps, and that's the limit of the flood risk. And it's like we keep trying to explain to them that the term firm is flood insurance rate maps. If you're not in the firm in the high risk area, it doesn't mean you don't flood. It just means your insurance is cheaper. But it's hard to show people outside of that special flood risk area what their risk is and how much rain could trigger devastating flooding. FEMA's using numbers like, for every inch of flooding in a medium-sized residential structure, it's about $25,000 worth of damage. And once you get out of the special flood risk area, there's hardly any uptake in flood insurance. And we already have problems inside the special flooders. So we were looking at all this stuff, and I was asked the question, well, can we not do a better job of modeling this, putting this information together, and develop tools to display this information that's both visual but also intuitive to the end users? And so this is what Odd and his team has been doing. They've been talking to a lot of people about how to present information that makes sense, how to look at data that would get them to the point of doing something different, either where they build or what they would do to mitigate, or how they would change their operations, or how they would look at possibly transferring that risk to insurance vehicles, because the event would be one that, although rare, may not make sense to put in the financial investments to mitigate it, but it would make sense to have the insurance in case it does happen. So as we've been doing this, it's trying to get to this question of, why do I have to wait for a disaster to occur to figure out how bad it's going to be? Why can I not use tools to look at both the hazard itself, and again, we're not forecasting what the trigger event's going to be. We're not forecasting how much rain, but we can take that and we take historical and we can go, if this happens in your community, this is how sensitive some of this critical infrastructure is to those impacts. And here are some dependencies in a way that you probably haven't always looked at. And so I'll let the other team get into the machine learning and all the stuff like that. But it gets to the question I've always tried to ask. We can do more to change an outcome if we have good information and can just get decision makers to think about where and how we're building differently. But if we wait to the disaster, again, we're cleaning up the mess and go back, and unfortunately, we'll probably rebuild it not much different than the first time, because everybody wants to get back to normal as quick as they can. And we're setting ourselves up for repetitive disasters. So with that, I'll turn it back over to Greg.
All right, great. Thanks, Craig. So we'll dive in a little bit here. I'll share my screen and we'll present. I'll dive in a little bit on our broad thinking about not just what 1C is up to, but really for all of us, what's going on in the world of technology and emergency management, something you guys are steeped in every day and have been for many years. But just how we're considering this, the numerous challenges that we face in this industry coming forward into the 21st century, based on a little bit of the history as to where we've been. So, we really are faced in emergency management. We're going to dive into this a little bit, so I'm going to be relatively quick. How do we capture, manage, consume, interpret, and use all of this information that's available to us in emergency management? How do we adopt and integrate new technologies faster and faster? Every, new shiny objects are coming out for us to consider. What's the smart strategy to do that? And we have a rapidly changing environment in the space of emergency management, disaster preparedness. There's more disasters. They're of greater complexity in a globalized and interconnected world with increased fragility in key areas, even though we harden other areas. We have a broader scope of responsibilities. That which emergency management was starting to focus on has expanded to any disruptive event. And so now we need to give consideration to that as well, to many things we didn't think of before. The economics, Craig spoke quite a bit there about the economics. That's becoming an increasing driving force. We'll talk about that. And we've somewhat politicized disasters, and I'll talk about that. But what we do know is that moving forward, and has been for the last few years, but certainly in the future, we can't have business as usual in the space of emergency management. Now, government is not known to enjoy adopting new technology. All of you work with that every day, and we're aware that government's slow on the uptake. There's myriad layers of resistance to new technology to ensure that we're spending the people's money smartly, which is good. It slows us down so that we're not just wasteful, so we're not too early in adopting a new technology. But at the same time, with the way technology is evolving now, it's going to be important for government and private sector to adopt earlier than it had in the past. And we'll talk a bit about that. Now I want to tie back to sort of the history of emergency management and how technology has driven how we're able to communicate with people, how we're able to get our jobs done. I mean, the fact of the matter is that the first, public alert and warning system for this country started before the country did. We've always communicated to people, whether it's through watchmen in towns or bells on church steeples or Paul Revere riding through the community, what's going on immediately. But it's a very local capability that we had, not even extending over whole cities, as we saw in the Chicago fire, where people on the other side of the city weren't even aware that the fire was happening. And as technology continued to evolve, a lot of it was just telling you what happened. We weren't tied together as a nation yet. We couldn't really support each other. We just found out what happened in far-flung places. But as it evolved even further, we were able to then communicate in real time or near real time. and seek to assist each other. This not only brought our nation and eventually the globe together, but emerging technology and communications allowed us to support each other in mutual aid and response. And I look at the San Francisco earthquake of 1906 as an example of where it's happened. There are major fires, and through telephonic and telegraphic usage, we're able to send resources while the response is still happening. But really, emergency management, and we're all familiar with this, didn't start until the civil defense era, when we had an existential national threat and allowed us to formalize our processes by which we monitor, alert, and warn people, and started the concept of broad-based emergency planning. And one of my favorite pieces of history in emergency management was crisis relocation planning. The planning assumption was always we'd have 3 days of notification before the Soviet bombers would come over the poles. So we'd have plenty of time to dump the major cities out through the newly built Eisenhower interstate system, and all would be well. Well, that was a really good return on investment in that planning effort right there. But through the, again, expanded use of technology, we were able to better communicate with our citizens and craft messages and alert and warn people as to what could be threatening them and what was going on. And during the same time as the Cold War, we started, particularly in the Midwest, with tornado warnings, and then the East Coast with hurricane warnings as well through an emergency breakthrough on television. But none of that really affected preparedness. None of that really affected recovery, and it certainly didn't build a lot of mitigation and resilience in our nation. It was back in the 1990s when we had 3 major events, and there were many others, but the 2 major earthquakes on the West Coast, and now we're getting into the disasters that most of us remember and everybody's read about. And the 1992 Hurricane Andrew is pictured on the bottom right, which just devastated Central Florida and led to a national conversation around what is the government's responsibility at the state, local, and federal level to educate the public at their risk, to enact building codes, to really prepare communities. And James Lee Witt, as the FEMA administrator at that time, and others in the administration started talking back in the 90s, started talking about sustainable communities for the first time. We also started adopting best practices. We started knowledge transfer amongst communities, which really evolved how we did business. The only technological advancement we really had, though, was the ability to capture and store data. We weren't really sharing, especially in government. We weren't tied into the internet till much later, the way we are today. So we could capture data, and that started to build the foundation of the copious amounts of data that we have access to now. Truly, our modern era began back in the early aughts. So we know what happened on 9/11, and we remember what happened in 2005 with Hurricane Katrina, devastating New Orleans. But what that brought was a real focus by our federal appropriators, our congressional leaders, and our state leaders as well, that it was time to invest money for both equipment and capabilities and capacity in emergency management. And we needed to recognize that risks that we have as a nation affect us all in many cases, and therefore we need to prepare to respond together as a nation and even globally in certain circumstances. But that mandated some of the standardization of planning and how we operate. And most of you are familiar with this. It was at that same time that rapid communication and interconnectivity changed our operating environment so quickly and so much that now there's an expectation that if it's happening, you know about it. There's no excuse for you to find out 6 hours later that the corner of walk and don't walk is underwater. You should have had that information access right away. And of course, now we have the proliferation of the internet, which allowed us to share data, information, and resources amongst each other that much faster. This started to bring a burden upon emergency management for an expectation of data access, information access, and information sharing, which the assumption was, well, with all of that, then you can respond faster, right? Because you know about it, you can do more. We had also been so well funded that we were able to do a lot more. But we were responding to disasters, and as Craig said, rebuilding, some focus on mitigation, but it really wasn't until 2008, 2009, where we really emphasized the concepts of true investments in mitigation. And now we're in this era of resilience, and we hear that term all the time, and it means a lot of things to a lot of people, but really a focus and an understanding that the inherent risks to our communities, our cities, our ports, our airports, our critical infrastructure And I know we know this now, but if we roll back in time 10, 11 years, it didn't permeate the zeitgeist of the country and the globe the way it does today. There's a fragility to how we exist that we need to harden against a lot of these risks and what have you. And so we started to understand that there are cascading consequences. If Manhattan shuts down and we close down Wall Street, there's an economic impact that ripples. If we shut down Minneapolis airport for a day and a half due to a disruptive event, well, that's cascading consequences through America's and the globe's aviation. So we need to understand these and plan together. And of course, now we started to incorporate global climate change considerations as well. What this means for emergency management, though, and concurrent with that, is we talked about all that data that's coming in. But at the same time, in the late aughts, and certainly the last 11, 12 years, our EOCs have access to so much data. And now we're adding screen after screen because we're told you have to. You need to be bringing in your local news on the top line. You have access to be sitting and monitoring the national news as well. And you need to be working with an ever increasing number of reliable internet-based sources for active data. And all of this you have to absorb and interpret as an EOC manager, as an operator, as a plan section chief, and what have you. It becomes very overwhelming. And then in the last few years, with the last 15 years, increased access to real-time video coming in. And my favorite is when you walk into like a Department of Transportation or an EOC and you have all of the highway cameras up there, and they're, it's a 48-inch TV, but there's an inch by an inch image from each one in black and white. That's sort of staggered images coming through. I'm not sure what that's supposed to tell us other than whether there's a flow of traffic or not, but we now have screens dedicated to that. Emerging technologies such as drones, and my least favorite emerging technology is such as social media. And what I mean by least favorite for social media is I remember distinctly, and we all have anecdotes, but afford me this one, please. I remember distinctly during Hurricanes Irene and Lee, which were two back-to-back storms that struck the Northeast in 2011, getting a call from the governor's office when I was the head of operations for the state, being told they had seen on Twitter that a small town had rioting in the Catskills. Okay. So understanding the op-tempo of my governor's office and knowing that we don't do anything small, we deployed the National Guard to go and quell these riots in this small town. So we invaded this little, bedroom community nestled in the Catskills and found that these two college kids had gone home to check on their parents, and their parents had fled the region, and the kids broke into the house, and the neighbors saw that and went and called and said people were looting. So not always reliable what you get. We did, however, manage to drive 9 Humvees and a couple of UH-60s into town and wake everybody up. But the point of the story is this is an enormous amount of unverified raw data that has to be interpreted by people. And as we deal with this ever increasing amount of information, the burden falls to us to interpret it and react to it. So what have we done in response to that? Well, as far back as 1983, and I'm sure some of you can place this image from the 1983 movie War Games, we decided building EOCs with giant screens so that we could visualize more and more data was the way to go. Now, true story on this, when NORAD saw the movie, they said, hey, we don't have giant screens like that, and we want them. So they went out and got giant screens like that. And ever since then, it's been a competition between states and cities as to who can build the EOC with the most giant screens and how big they can possibly get. But when we look at an EOC, a contemporary EOC, there's an enormous amount of data and information coming in. And the fact of the matter is that we have exceeded how much an organization, let alone a person, can absorb and process. It's not just reading it, it's remembering it and putting it into a process as well. It's completely overwhelming. Now, concurrent over the last 20 years, longer than that, but in particular the last 20 years, when emergency managers like me said, oh, wait, my GIS guy has something to offer to me, GIS has done a phenomenal job of really building along with us integration of information so that we can visualize it. There's analysis in here. You can quickly, this is from today, we can quickly see where the fires are across the United States. And I bet every one of us went, without even using the key on the bottom right, okay, the bigger circle means bigger fire. So you're able to assess if you're sitting at FEMA headquarters and say, where the big fires right now in the US, and then click on one and get additional information. We've started to translate that into useful information to the public. New York City's evacuation zones. accessible and consumable by John Q. Public so that they can understand where do I live, and they can, of course, deep dive into this. But just a quick visualization on the landing page shows you the extent of the risk, the severity of your risk, and if you can mentally map where you live or where your interests are, whether or not that, how much that could possibly affect you. And of course, this tool goes much deeper than that, as you're familiar. But flood planning has been something where GIS has led the way and increasingly incorporating various data layers that allow for that analysis and the early adoption of machine learning into GIS so that we can produce tools like this that not only visualize where the water may go, but really give us an understanding of our risk. And we can quickly extrapolate things that we can do about that, or things that we should do. For instance, if this were a predictive analysis of the next 72 hours, where should I be evacuating? Where you've taken it that you didn't mean to take it is the private sector's adopting it now. So in emergency management and overall national resilience, what we're seeing is they're using the tools that you've built over the last 30 years, 40 years, in particular, more recently, and now it's reached into the private sector. So if you go to search a home on realtor.com, it's going to give you the information about that home's flood risk. That's incredible. That's a wonderful evolution of government building good things, investing in good things, and seeing the private sector take it to the next phase to inform people as to what's going on and help them make better decisions. Will they always do that? Absolutely not. But if we can turn that knob a couple of degrees every day, then we get better, we get stronger. We know that over the last 40 years, as this depicts, we've seen an ever increasing number of meteorological, hydrological, and climatological events. Earthquakes, tsunamis, and volcanic activity, that's on the Earth's timetable. We don't do anything to affect that. Fact of the matter is, you can see, though, that we have an increase over the last 40 years on the other three types of event, as well as the severity of those. And what we're finding and what we know is that the insured loss and the uninsured losses are going up dramatically. Now, 2005 is this big spike in the middle. So we understand that's Katrina, of course. And then we have a bad wildfire year in 2017, as well as several major hurricanes. And what we see in that is about a 50-50 split, maybe a little bit less, of insured versus uninsured. And what that's leading to is the analysis globally that there is inequity between the people of the earth and who has insured coverage for their probable losses or potential losses, and who does not. But if we look at the billions, these are in percentages, even in the United States, 47% is insured loss, which means that 53% of it falls on the government or falls on the person who experienced the loss. There is a push, and I share this because there's an enormous push now, and these are the conversations Craig was referencing, that our company's engaged in, that many companies are, with the insurance industry, because government's saying this is no longer sustainable. We can't have $21 billion disasters per year, as we've had 4 out of the last 6 years. We can't keep having that happen. We can't keep spending this amount of money on recovery and not getting stronger. And the insurance industry is saying, we want to work with government and emerging technologies to identify how can we do risk transfer? How can we make sure that we're giving products that are going to, yes, generate revenue for them, but at the same time, ensure the risk that communities and individuals and families carry, and businesses as well, so that this is a much more balanced reality. That's what we're finding in the marketplace. That's where we're hearing the greatest pain point, are not just the physical loss and the response, but the economic impacts. And that's why business no longer can be done as usual. The last thing I want to point out is something we've all experienced. That's the politicalization of disasters. And that goes to another drive of why we have to be good about technology update. Ever since Mr. Bush overflew Katrina, governors and presidents have realized the political opportunity of being very hands-on during disasters. I would argue that even, perhaps Mr. Newsom shouldn't be breathing the air he's standing there and breathing at that point. But my point is, we get ever increasing pressure in emergency management to ensure that our political leaders are actively aware moment by moment as to what's going on, and we get pressured what's going to happen next. Of course, we don't have a crystal ball, but we do have ever increasing number of tools that can support us in assessing that. So really the field of emergency management is evolving to recognize 4 pillars: really comprehensive, deep dive, multi-layered risk identification, including cascading consequences between various sectors of critical infrastructure, various economies, various communities. Focusing on risk reduction, of course, preparedness, but financial protection. Okay, and this is a key one: increased financial resilience for governments and individuals. We create way too much poverty or exacerbate existing poverty. We create underhousing, underwork, or house loss and work loss through natural disasters every year in this country and around the globe. And we need to focus on that pillar. And then truly resilient reconstruction, not just making a culvert from a 4-foot by 4-foot culvert to a 6-by-6, but truly looking comprehensively across a community and making the best return on investment, ensuring the best return on investment for every investment we make. The amount of data that we need to access in order to do all of that is quite comprehensive. I want to real quickly just point out, though, that the humans like us who are tasked with doing that have to look at that situation, consider their options, choose, act, and evaluate. Steve was a pilot for a long time, still is, apparently always flying to the North Pole from what I heard from declination comment, but okay. 14 West is mine, Steve. So anyway, we have to consider all of our options. And you saw the screen of the EOC. How much information do I have to wait to have come in? Do I wait because I'm going to get another updated report? Is there a data layer that I haven't gotten that is critical to the decision-making that I have to make? Well, back in the 1960s, there was a psychological study done, which is the most cited psychological study in the history of the industry. And it's been proven again and again to be absolutely true. The name of the paper was the magical number 7 ±2. But the key salient points are human beings can only remember 7 chunks of information at a time. Okay, that's really what we can put into short-term memory. And from that, we can come up with 4 to 8 identifiable alternatives. If you're giving me, as we went through this quick review of thousands of data points, what 7 chunks am I supposed to choose from? GIS helps narrow that down, of course. But there are other factors that diminish my ability to process information quickly. And we're all familiar with this. And you all work in emergency management, so you know how stress and exhaustion and hunger and your experience and your biases can affect your decision-making. So this really isn't this environment is not supportive of making sound decisions with all that data that we have access to today. So what we really want to do is we want to come up with a pro and con list. And I want to walk you through real quick to keep it light on the first pros and con list ever created. When Charles Darwin was trying to decide whether to ask Emma to marry him, his longtime girlfriend, he sat down and he created what Ben Franklin would later call the world's first pros and cons list. Now, before I show you what he wrote down, I want to remind you, this was some period of time ago. These are not my words or my perceptions of the sexual politics of a relationship and the relationship between men, women, or partners in today's day and age. But the list that Charles made was pretty positive. Okay, and I'll let you read through that for just a second while I take a sip of water. So those were the pros. And then he said, okay, well, what are the cons of being with Emma? And so he counted those up and he said, well, it's 7 versus 6. So clearly, and he literally wrote this on the note that he later handed to her, which is an incredibly romantic hallmark moment to hand your wife your pros and cons list when you ask her to marry you. QED, so it shall be. All right. The first pros and cons list, and really taking multiple data points, lining them up, finding where you can cut them in half, and weighing towards the probabilistic best outcome. And that's artificial intelligence. Artificial intelligence is predictive. It is not deterministic, okay? It takes those data sets and assesses those, and we'll look at that in just a second, a real basic walkthrough of how it does that through the use of efficient algorithms. And now that we have all this massive computational power, it allows all of those data points to be assessed in milliseconds, as you're well aware, to find those hidden patterns and weigh them out into, if you will, pros and cons as to what is the probabilistic most likely outcome. Now, whenever we talk about AI, people get a little nervous about the Terminator. There's supervised or narrow AI, where we can train something to do a few things. And then there's general AI, where Arnold Schwarzenegger gets to take over the world. Anytime you're worried about general AI, I would offer you autocorrect as a current example of the status of narrow AI, okay? If they can't figure out autocorrect, I'm really not concerned about Skynet becoming sentient tomorrow. But the fact of the matter is we're in this world of narrow AI and will be for the foreseeable future. And what we've been able to do, and I'm sure many of you have seen the example of teach the computer and build algorithms that assess the various characteristics of the apple. So when shown an image of that object identification later, the algorithms can determine, yes, probabilistically, not deterministically, this is an apple, not a pear or a banana, based on all of these characteristics that a human over AI and a human in the loop said, this would be positive for an apple. We use this every day, object identification, to dig out your zip code. You use it if you speak with Siri. So it's not uncommon for you to be using AI. What this means for us in emergency management is if there's a hurricane coming F and I have to decide if I'm going to evacuate X, it's just not that simple. There's a hurricane coming, I'm going to evacuate. I have to consider other variables as well. There's a hurricane coming F, do I evacuate? Or, excuse me, I did that wrong. The question to solve for here is F is, do I evacuate? X, there's a hurricane coming. Well, X1 would be, is it going to hit a populated area? X3 would be time of day, density population, the risk, the flood risk, the surge. I mean, there are, as you know, hundreds and hundreds and hundreds of superficial data points that we consider when making evacuation decisions, let alone the tens of thousands that actually go into it, like data layers related to topography and geography. So we do this with those brains that we bring to the conversation now, which can only handle 7 or 8 chunks of information and come up with 4 to 8 options for us. What the computer does, just like Charles Darwin, lays out on either side, if we take the pros and the cons, if you will, and we lay them out, and they easily divide, then we can draw a line through that and weigh it just like Charles did. Typically, though, there's going to be both positive and negative. There's going to be some data suggesting one way and some data suggesting the other way. The way we overcome that is we add another dimension to the conversation. By adding that x-axis, we're able to now weigh it out. We're all familiar with these charts. As we get more and more data points entered in to whatever we're trying to solve for, that function that we're trying to solve for, it can get increasingly complex. So we add yet another dimension, and through 4 dimensions here, we can drop a plane through the middle of this, cut this box off and weigh out. Obviously there's more blue than there is red and go in that direction. What the computer is able to do is continually add dimensions and continually add dimensions so that it is cutting and considering and adding probabilistic outcomes and assessing those over and over again, far faster and more effectively than we ever could. And if you're familiar with the Marvel movies, that's kind of the inspiration for Jarvis, the AI tool that Tony Stark used, where we see this accuracy. This only goes up, this is a little tough to read, to 2016, so 5 years ago. The object identification and then probabilistic behavioral outcomes assessment being used by the early versions of driving cars was all the way down to 2 to 4 errors, okay? Only making 2 to 4% of error. A human makes 5 to 7. So back in 16, the computers got faster than we did with object identification, meaning that it can track faster. And that's why now we're finally starting to see some automation on the roads in our vehicles. So what are we doing with this? Well, and one concern, as Craig talked about, we're really trying to take a deeper dive and apply the machine learning to the various data sets that we have access to. So this is a very early version of HAZUS. You guys have seen this. This is the 2013 earthquake up in Sonoma County. And I've used HAZUS for years. What does this tell me? Whether I'm using it as a simulation or a real world event. First of all, HAZUS can be a little slow. But second of all, okay, I know I've had an earthquake and I know where the damage is. And I know it looks like it's pretty significant damage because it's bright red. So that just intuitively tells me that. But it doesn't give me the details that I might need to really make response and recovery decisions. And it doesn't tell the state knows they had an earthquake. It doesn't tell locals anything. They're going to have to drive around and find out. It doesn't tell the state they know they had an earthquake, but are they starting to move the task force out of Los Angeles Fire Department, or should they just drive there and see what's going on and communicate that way? And it doesn't tell the federal government much at all. It's better than nothing, but we can do better as an industry because we know that the data sets available can be incorporated into our assessments, our both pre and post disaster assessments. These two homes exist in that zip code. Admittedly, the one on the left has been being renovated in the picture. This is before the earthquake. This is after. The house on the right was retrofitted. Okay. It didn't have any exterior damage. I'm sure some things fell off the shelves inside. That's a survivable home. I don't need to start search and rescue in that house. The house on the left is shaken off its foundation. It's got structural damage. This house is getting torn down after this earthquake. Okay. The data set that tells us how these two homes were going to behave was the retrofit, which was on file with the city. So by incorporating that, we can make much better predictive analysis as to what could happen. And what we see here is our ability to zoom out and start to see at a broader level with our tool. And these are early experimental capabilities that we were developing. Exactly how would those buildings behave? How would neighborhoods behave during an earthquake? So that we can understand. And then by adding increasing data layer sets, right down to the street level and the building specific, in this case, a hospital, how would that behave? So if there's a moderate shaking, this is actually a 6.0 northwest of Anaheim, perhaps. Regardless, wherever it is, we would say, wow, big earthquake out there. We need to check it out. Tools like this can help you identify how bad is bad and where do we start looking for. This is predictive. It's not deterministic. Where do we go start looking for that damage, particularly these bright red damage where people may need immediate life safety interventions like search and rescue. As we move forward, we can do broad-based, incorporating all of these data sets, do better and more comprehensive scenario analysis, and then run a series of, this is only 80 simulations, but we can kind of see based on 80 simulations, geez, where's the highest risk in the city of San Francisco for more significant damage following an earthquake? I mean, there are scenarios where the whole city's looks like it does in that Dwayne Rock movie, San Andreas, but it helps communities prepare for response, for recovery, for investments in mitigation. So as Craig said, we started on seismic, and then we quickly moved into flood because that's the disaster that causes the most damage, is most frequent, and the most loss of life every year. And right now, this is a screenshot actually of our live product in Kumamoto. We're doing live flood. There's a lot of live flood predictive tools in the United States, not so much in Japan. So we have a great relationship in Japan with several prefectures and cities and private sector insurers, to be honest. And what this allows us to do is go and take and look in real time and analyze, all right, there's no flooding going on in Kumamoto. This is a simulation we ran though for a flooding event based on forecast rain. And what it shows is at a resolution of each of these hexagons, where the flooding will be in the depth and the number of people anticipated to be impacted. And by adding machine learning and drawing from the updated forecast models that are coming out of the Weather Service in real time, able to update this in real time so that the line at the bottom changes as you draw forward. You can play the whole movie, so to speak, and see how the flood will behave in that community and when it will peak, so you can make your interventions at that point. Craig also talked, what we're finding in the US and with the global, the Fortune 500 companies that we're working with, is the real interest is in critical lifelines and interdependencies. I don't really care about my warehouse. I can build warehouses all day long. In fact, the stuff I have in my warehouse is insured. What I care about is supply chain. And boy, didn't that come to fruition in the last year in two ways: COVID disrupting global supply chain, and then the Greenpeace sliding sideways in the Suez Canal and further risking global supply chain. In order to, so when you talk with private sector companies and even governments, you find out, wait, you are way over insured on the physical damage to an earthquake or a flooding event for your physical property. What you're not insured appropriately against, and we're not selling insurance, we're really looking at it through the risk management. What you're not managing the risk of is the disruption. If you lose power, if you lose fuel, if the trucks that supply you can't get to you for 5 days, what does that mean? So now we're working with companies to help them uncover hidden vulnerabilities based on their dependence. And what that allows us to do is not only give them a vulnerability map so they can make smart investments, both mitigation, investment in new property and locations, but calculating downtime for them as well as first to fail. If I have X scenario, what of my dependencies will fail at what time? If that scenario increases due to climate change, due to incident hazard severity, how does that change first to fail? And in a timeline, how does that evolve over the course of the hazard? So that's what we've been building over the last 5 years, and are now working, as I said, with many companies to validate this in the field. And so I'm going to come back to validate in a second, but you're going to hear, and I'm sure many of you had, because our doors get knocked on in government all the time by vendors. Everybody's using, we've got AI. AI is part of our technology now. Well, we need to ask good questions when we ask about AI. Is it scalable? Okay. Is it dynamic, or will it become dynamic? Okay. How do you continually validate your tool? One of the big differences between, and I say AI, it's really machine learning. One of the big differences is back in the 90s, we'd buy software, heck, in the aughts, we buy software, you get it in a box, you install it, and it runs, and that's it. Now we might get a download update, but Windows 95 was Windows 95, right? Excel spreadsheets and what have you. Now, what we need to do, what's happening is the AI and the machine learning behind it, as well as often the user interface, is updating so quickly that we have to understand with new tools, how is that going to continue to change over time? What are the biases that have been brought by the team to create the AI algorithms? Human has to write them. Humans come with biases. Are you leaning towards greater damage? So for instance, we scale ours up several percentage points towards a more worst case scenario, because it's better to overpredict than underpredict, particularly when you're dealing with response like live flood. Then you want to look at their intellectual honesty and how transparent they are and how effectively their tool will communicate. And what does that mean for us in government? Yes, many of you still in government, me from government, Craig from government, probably back someday at some point. We need to take a greater leadership role in the technology. We don't just need to go to conferences and hear what they're saying, they're developing. We need to drive that conversation. With AI, the cool thing is, with machine learning, the cool thing is, it's what's the problem I'm trying to solve? So go to those developers, go to those software developers and say, here's the problem I want to solve. Okay. They should be helping to identify how best to solve that. Here's the data here. What else? What other data should we put in? We need to standardize our data sets. Data's a mess out there. We need to get that standardized so that we can quickly adopt it for ourselves. And for the companies, we need to work on standardizing data protection, privacy laws, and regulations in this country, because it's incredibly diverse from jurisdiction to jurisdiction. That's going to slow not just the adoption, but the creation. We need open data. We need to open data appropriately. I'm not talking about personally identifiable data. I'm not talking that which can harm people or give businesses a competitive advantage to take advantage of people, but rather, fix these privacy laws and open data a bit. What we really need is early adopters. Okay. I've kind of already covered the last point, but we really need firms, Andrew Ng, spelled NG. Andrew NG is his last name. I encourage you to watch. He's got a couple of YouTube videos about machine learning. We got to get AI out in the field early, when it's like a minimally viable product is the term. Get it out there, get some data into it, and start validating it so that it can be built upon. That's how AI is different than traditional software. We can't wait until a solution is, 15 years of field deployed before we procure it. We need to work early with developers of this type of technology. Now, what Anand and I are doing, and he's going to be taking questions and correcting all the mistakes I made in this presentation, but what Anand and I are doing is, we are not looking to sell to governments or academia. We are looking to talk with government and academia, because what we'd like to do is do a deeper dive into our solution, not to sell it to you, but to have you poke holes in it. We have use cases and assumptions that we're coming up with for private sector. We need government experts to take a look at our solution and say, you're missing this. This makes sense. That doesn't make sense. So I'm hopeful that some of you may be interested or have colleagues or friends and family that are interested in government who would spend 30 minutes with us. Let us do a deeper dive, show you what we're up to. Again, let me be clear on this. This is not a sales pitch. We are not looking to deploy to government at this point. We are looking to understand, does this vision align with what you're hearing and what you're doing, and how can we work together? So that's what we're up to. And with that, I'll turn it over to questions for Craig and Anand. Hope that was interesting.
Thank you very much, Greg. That was great stuff. I'll open the floor. I've got a zillion questions, but probably other folks can maybe get the process started. Or Randy Knipple, I'm going to call on you because I know your brain's spinning a million miles an hour. What do you got, Randy?
Well, my first thought is, it'd be really interesting to do a workshop with you and just talk about what we're doing in Minnesota with data standardization and open data policies and things like that. In some ways, Minnesota is behind in the open data arena, but we've been pursuing it and advocating for it and encouraging other counties and cities to consider moving to an open data model. But we also, we are the Emergency Preparedness Committee under the Minnesota Geospatial Advisory Council, and we've adopted multiple data standards, and we really see the issue with data being that where the federal government, in having an absence of data, was spending millions of dollars on, large corporations to go and pull data, and using some of these large data providers that are out there to create these national data sets. But at a local level, they just don't hold water because they're either not accurate enough or not complete enough. And so the best model is to get the data from the local level and feed it up through the hierarchy and have it contribute to those national data sets. And so that's really what we've been trying to do in Minnesota, is counties play a facilitating role in assembling data and engaging our cities in providing updates and refinements to that data. Counties might work with a regional organization, like here we have the Metropolitan Council. We have an organization called Metro GIS that has developed some standards so that in the 7-county metro area, we have regional data sets for address points, street center lines, property parcels, and we're working on others as well. And then that has fed into the statewide data standards. Again, in the absence of having national data standards, we're just doing the best we can to pull this stuff together, as well as encouraging various government organizations at different levels to all work together collaboratively and feed this stuff up. And so I think it'd be really interesting to I gave you a 50,000 foot level, but it'd be really interesting to share that in a little more detail with you, get your perspective on that. Perhaps you would consider using some of the data in Minnesota as for some of your modeling, with again supporting the whole idea of open data and collaborative data development and maintenance.
Randy, thanks for that. I appreciate that. And that's the kind of conversation our data science team wants to have, is to understand, because they're part of other conversations in other geographies, and they want to be able to point people to people like you to say, hey, maybe not, 57 flavors. Maybe we should have a pathway like you described. So I took your name down, work with Steve to get connected with you. And if you don't mind, we'll reach back with our data science team. Anand, anything you want to share with that?
No, I 100% agree with that. I definitely think that some of that data can be valuable for us also from a validation perspective. And so certainly we would love that.
If I could.
Well, and there's some synergy there too, because, then by you being able to use it and show how the data can be used, it reinforces the message that we're trying to convey, that this is important work and everybody needs to engage. So I think that's beneficial, mutually beneficial.
100%.
Randy, just give them an overview on the issue of Metro GIS and its long running. Again, that'll help them understand the umbrella that already exists across the Twin Cities, driven by the fact that you had these two metropolitan areas right next to one another, and the long running need to try to be able to be conversant in data. Just give them a snapshot on that. Okay.
Well,
Right.
the snapshot is, it's difficult to get certain personalities within government organizations to think collaboratively, because the tradition is much more of turf and control, and getting people to play together, getting the 7 metro counties together to work with the Metropolitan Council. I mean, it was more of an adversarial relationship, and you pretty much had to drag the counties to the table. This was a long time ago, before me, long time ago, but I pretty much had to drag counties to the table, and the Metro Council did it, but with financial incentives. Counties were developing data, and council wanted it, and so they came up with a chunk of money to give the counties an incentive to bring them to the table. And then there were some additional funds provided along the way to provide that ongoing incentive. And then it slowly trailed off, and there's no more incentive anymore. Now we do it because we want to, And so you have to kind of work with what you have. You have to work with those who are willing, and it's a much different world now. People understand more about the need to work collaboratively. Government has reinvented itself in a lot of ways, and you still got some sticklers out there, but that's really what happened in the metro area. That really became kind of the core representation of the collaborative model that has now been driven to the state level. And I'm proud to say that in a lot of ways, I think the 7 metro counties provide the model for the rest of the state. I mean, there are other counties, and we're not alone in that. There are still some counties that don't want to participate, but it's really more of a coalition of the willing to drive these more innovative approaches to how we work with data. We work for elected officials, and they're stuck in the mode of, well, if we're generating all this data, we're spending taxpayer dollars to generate this data, why aren't we charging for it? And it's tough to make that argument, but you have to. And the way we did it was by all 7 counties working together to create the consistent arguments and the consistent message about why we needed to have open data. And we all took it to our boards at the same time. And so we could leverage each other in that way too. And so every jurisdiction is different. The unique thing is that we had this collaborative arrangement that took many years to really turn into something that was much more collaborative, voluntarily collaborative. But I think that's the future. And that was part of our selling point for why we needed to have open data, why we need to have open standards, why we need to contribute to regional data sets and state data sets, and ultimately at the federal level. But, that's just not understood. There isn't any overarching government entity or organization to drive this. I mean, at the federal level, we got the USGS, we got the NGA, we have FEMA, things like that. The best they can do is come up with guidelines. FEMA certainly, Craig, I got to hand it to you. You wrote a letter a while back in promoting the use of the U.S. national grid that was pivotal for us, because that gave us something to point at and say, here's the director of FEMA and supporting and encouraging this national standard. And it was just that one piece of paper. I think we've still got it on our website, Steve. But that was pivotal. And so, but you couldn't force it to happen. That's the thing. All you could do is suggest it. So I don't know, I'm going around and around in circles, but
I know I really like your example. This is the way I explain things at the federal level. We don't have a lot of levers that we can pull for local government. We can't tell you to do something. We can bribe you through grants. We can extort you by saying if you don't do this, we won't give you the money.
Right.
But it's funny to me because I think you pointed out, once it gets going and people say, hey, this is adding value, then you don't need to have those drivers. But getting people to do something new or different has always been a challenge. And again, when I got to FEMA, the leadership there treated GIS as cartographers, like print me a map. I'm like, why are you printing maps? Well, we want to look at the data. I'm like, by the time you print the map, the information is already changed. Why aren't you just looking at this on your monitors? And they're going, you can do that? I'm like, oh, this is going to be painful. So yeah, things like U.S. National Grid. And again, that was, you know, it was only as good as the information that was being fed into the system. And that's where I kept finding these gaps of how do you fill in the gaps? Why do I have to wait for the reports to come up to start, you know, to best? So that's a lot of what the team at, you know, One Concern was looking at is, can we forecast better based upon the scenarios we're inputting in, and then use that to kind of level out all that information. But yeah, trust me, when I got to FEMA, I went into the operations center and they had maps pinned up all over the place. I'm like,
well, I do want to challenge you all on the maps thing. I mean, really quick story, because when I was first introduced to the National Grid, it was all about paper maps, and my reaction was I was a programmer. You know, we don't do maps anymore. We do apps. You know, it's all computerized. And then I realized that, you know, I was trying to send the message to fire chiefs and, you know, firefighters, ultimately first responders. You know, and the technology is a little bit overwhelming for them. You know, ultimately, if, you know, we can't, all the technology is really good, but ultimately it can become our Achilles heel if we're too dependent on it. So the lowest common denominator is still a printed map. The nice thing is we don't have to print 1 million copies and it costs us millions of dollars. We can have PDFs out there and we can print them on demand and we can regenerate them as often as we want. You know, it doesn't cost anything. So, you know, it's a checkpoint in time for the data, but it's a very lowest common denominator, simple tool that can be used. We can print 8.5 by 11 maps for pennies and hand them out to the Red Cross volunteers and stuff like that, or to search and rescue teams. You know, we don't have to worry about, well, we don't have enough iPads to go around, or you got to download this app, or you got to do this, that, or the other thing. So, you know, that is still the lowest common denominator. So I'd like you to just adjust your message a little bit.
Trust me, we had paper maps even when I left because GPS and other things were hackable. I was looking at single points of failure when cyber attacks occurred. So we went high-low. The high-end data systems and doing more with that, but defaulting back to sending my national IMAT teams out to remote locations, and all I give them was a grid number.
Yeah. Right.
And go, come find me. And you can't use your phones, your apps. You got a map, you got your little grid reader, find me.
All right, cool. All right, we agree.
If I could jump in and ask several questions, I'll just do it kind of in stream here. With regard to the interdependencies of infrastructure, it strikes me, first of all, how closely that aligns to the work that GITA did in the GECKO program and working through how all elements of infrastructure are interconnected. Some of the examples that pop out are the tunnel failure in Baltimore, where they got a rail train caught in there and it burned up a bunch of cables and all kinds of stuff came down. Florida, through Mr. Fugate's work, or Administrator Fugate's work, The classic example of if you don't have electricity, you can't pump gas. Those all that stuff hooks together. The next thought I'm going to jump over to is to Anand is the issue of in Japan. I just wanted to make sure you're aware that Honda has a system of reporting, and I'm sure you're tuned into this, that actively monitors on all cars, similar to what some of the systems are in the United States. My question to you would be, are you collecting that historic data and using that in your modeling?
Sure. I'll start with the last one, with the last question around the Honda one. Regarding historical data, we typically will collect data after an event. And so we have collected historical data sets ourselves in Japan. I actually wasn't aware of the Honda one, so that's pretty interesting. We may want to collaborate with them to try to get some of that data. But certainly, we have to validate our models anyways. And so because we have to validate our models, we do collect a lot of historical data, both on earthquakes as well as flooding, since Japan sort of has everything, unfortunately.
Right.
And so we typically will have historical event data sets, and we get that again from both from our own collection as well as partnerships. Mm-hmm. In Japan, of course, we work with a large insurer there that's helped us with our government relations to then get some of that historical data from the governments. And then the second thing is there are also a few, I'm actually blanking on the name, but there's a couple of, it's like Kokakyu Kogyo or something, I forgot. There's a specific company that actually does after disaster event collection. And so we're trying to collaborate with them as well to get additional historical event data.
Okay.
So that's the community.
Yeah. So again, GITA did a lot of work in Japan through a program, the RADAC program, I think is what it was called at the time. Mm-hmm. And again, just another item of awareness, probably the most detailed infrastructure data for disaster preparedness and response exists for Kyoto because of the issue of it historically being the capital, and a large number of the buildings there remain in the historic registry. And for the purposes of fire control, you don't want to burn down, wooden buildings stacked right next to one another, burn real easy. So that might be an area of interest to you. Standardized data sets, I just wanted to make a comment on that. One of the interesting things we've run up against in one of our project teams with working on the issue of underground infrastructure is that the leap that we want to see made there is the leap towards the ability to bring augmented reality into the cockpit, if you will, of an excavator. And the only way that we're going to get there in the future is to start refining and standardizing the collection of data sets now. Because if we don't, so that could be another push along your AI stream, that if we're not collecting that data with that level of accuracy now, and we're working within the American Society of Civil Engineering spectrum of what level we want to define accuracy to, that needs to be the thing that drives the data collection, the standardization now. The sharing of data, of course, ends up being the Achilles heel when you start moving across the spectrum of utilities and the rest of it. And we've found that the United Kingdom is way ahead of effectively the rest of the world. They started in 2006, and through things with the Scottish Vault and the High Commission, those may also be things that are of interest to you. And last but not least, I wanted to ask whether or not you're familiar with any of the work that's gone on at Florida State University. It appears to me that you're using building footprints for your the drive of your effort. But Florida State is in response to responders in the field that when dispatched to an area to try to figure out where they should concentrate their efforts in response, had asked for a way to develop better granularity without using building footprints. Because, for instance, you could have a tobacco barn and there's nobody in it if you're looking at a building footprint. So instead, what they've done is circling all the way back to where the discussion started with our USNG advocate, Randy Knippel. They've used USNG to map against population index down to, I believe it is 100-meter grid squares, so that responders into the field would have a better sense of from the data-driven element of where to go to look for a body in a structure, if you will. So just another thought on the spin of your data. That's
super interesting. Thanks for sharing that. Yeah, and I think we'll definitely look further into that. From our perspective, one thing we do use building footprints, although we also have demographic data. But I'm not sure our demographic data is at 100 by 100 meter resolution. So that would definitely help us at least give that more of that clarity to like that really is, particularly from a use case perspective. It sounds like from an emergency management perspective, that's really what would be most helpful. And we hope that our, layering that on top of our modeling, and because our modeling is unique in the sense that we couple a bunch of different models, so that, from a user perspective, there's just one inundation model, but it takes into account all types, urban and coastal and riverine flooding. And so I think if we could overlay that with some of the data you just mentioned, that 100 meter by 100 meter demographic data, that could really be a great enhancement for us.
They just released it, and I'd be more than happy to coordinate with Greg to get you the point of contacts at Florida State University. One last thing, if I could, Corey Richter is. Are you still with us, Corey? Yes, she is. She's just taking on the role of, soon to be announced or whatever, chair of the overall Minnesota Geospatial Advisory Council. And perhaps there's something we could work that would facilitate better access and better exploration of your efforts across the state of Minnesota versus it just being in the metro area. Corey, the floor is yours, please. Sorry to throw you under the bus.
Yeah, you put me on the spot here.
Yeah.
Well, I've been thinking about a few things and I've just been quietly listening this entire time, because for me, where this crosses over, it obviously crosses over a lot with the efforts with the underground utilities. It crosses the efforts with critical infrastructure. And then everything that, Craig, when you were talking about those items, when people look downstream or upstream, what are those things that fail, that cause failure at your facility? You could have the most ironclad facility in the world, but if something else goes wrong upstream or downstream, and that crosses with all of my asset management folks that are on the periphery of this, because that's exactly what they look at. They look at probability of failure, and they look at the consequence of failure, and they give it the criticality scores there. So we have both our geospatial community here and with the MGAC, the Minnesota Geospatial Advisory Council, and the interest folks have there, and our Minnesota Institute of Asset Management chapter, that they all will have some sort of interest here. So yeah, I mean, I'll go back to continue pondering and quietly being here in the background. But if there's anything, I think this could potentially be something we could, with the power of Zoom and WebEx and everything else, we could potentially bring you out to speak with the GAC or some of our other groups here in the near future.
We'd appreciate that. And, having some of our data science members join who deal in the world that you deal in every day of trying to find data and figure out the best way to use it, what's out there. You guys are on the ground doing it, so thank you.
Absolutely. Yeah. And standardization of data.
Standardization and changing the narrative. I want to point out we need to change the narrative, because the only thing the public and by extension our elected leaders ever hear about are data breaches, right? What is the, you say data, everybody thinks Facebook is selling my data, and I'm just picking on Facebook. It's all the social media, and they read headlines about how this credit card company or that store had a data breach and my data's been stolen. They don't know the good stuff that you've done with data, like, hey, data in our community and data about your home helps us alert you if you're going to be under 4 feet of water in 3 days. They just look at it through that negative lens, and we need to help recapture the narrative around that.
And Minnesota is a great spot to do some of that, because there's been such a push that we actually have more than 50% of our counties have now officially adopted an open data standard policy. So in the state of Minnesota and pretty much all of their contracts with data that comes in there, there's this idea that it's all open data, that it's publicly available. And we're not doing this fee for service, charge once, use many times.
Awesome.
So that's a big push along for us in Minnesota, is that idea of sharing, collaboration, and making things open when it makes sense.
Well, you all have been very generous with your time today. I had shared my contact information. Steve has my contact information. I can connect you with Anand and Craig, and we'll look forward to circling back with some of you. Appreciate that offer, Corey and Randy, to do that. Is there anything else Anand or Craig can answer for anybody?
Well, thank you very much. You have also been very generous with your time. I know that across the spectrum of your efforts, we are a small potato effort, and to the degree that you would be so kind as to offer this presentation, it is greatly appreciated. And as I've indicated, if there's anything we can do to help move your efforts forward, you can please, by all means, call on me, and we'll see whatever we can do.
Thank you very much. I really appreciate that. Anand, Craig, thank you both for your time. And I would just want to thank everybody for the hospitality.
All right. Take care. Thanks, everybody.
Talk to you soon. Thank you.
Bye-bye.